Welcome to E-Bits.
Hello, and welcome to the Mining Engineering. My name is Begim Kalipi.
And I'm Yanni Maritz, lecturer in the department. And today we're going to talk to you about what's happening in the mining industry and how we extract all this raw material needed to get this instrumentation and technology.
We are also going to introduce to you a little bit of taste of the South African mining industry. We're going to look at mining engineering as a career, and of course, we're going to look at our department in the University of Pretoria.
So, Becky, can you tell us what is mining engineering?
Mining engineering is actually the application of science and technology in the identifying, planning, and actually economically extracting mineral resources from the ground. And of course, we have to do this in a safe and an environmentally friendly way.
So what you're telling me is that the mining engineer will be involved in all the processes from extraction all the way through to beneficiation and then also selling of the product.
Definitely, and that's right. But it doesn't mean that they're expert in that, but they will have enough information so that they know exactly who to consult in the case where they work in the mine. And it involves 5 main cycle or stages within the process of mining engineering, which is exploration, which is mine planning, production, transportation, and beneficiation. Now, and throughout all these stages, they work with geologists in the exploration and the mine planning section. And of course, as they move towards production, that's when they start to work with mechanical engineers, electrical engineers, chemical engineers, and other engineers. But as they move towards processing and beneficiation, that's where they work with metallurgical engineers.
Okay, so we truly need to be interdisciplinary skilled.
Exactly.
So, what are the minerals that we mine in South Africa? Well, South Africa being one of the countries that's greatly dependent on fossil fuels, we still use coal for power generation. We have 15 plants for that, with 2 uranium plants where we actually produce nuclear power.
Very well. In 2016, South Africa formed part of the countries that actually signed the Paris Agreement, committing to reducing their carbon emissions by the year 2050. Therefore, that means we have to actually migrate into new, clean, and renewable energy as a country. That is why we are focusing on wind power, solar power, and energy that is stored in batteries. And for us to create those systems, we still need to mine some of the elements that you see in your screen.
So therefore, we're not just mining for jewelry. We also have the manufacturing as one of our clients. So we are mining silicon, gold, platinum, iron ore, even rare earths metals.
Definitely.
And believe it or not, we even mine the stuff that we put in toothpaste.
Wow, that is so interesting. It's amazing that nowadays everyone has a screen in their hands. But what people don't know is that actually in the screen that they have in their hands, about 50% of those minerals that are used, or should I say elements that are used to create those screens, are actually mined. And the ones that you can see that are in red have a recycling rate of less than 1%. It means for us to continue providing people with screens, we need to keep on mining.
And creating jobs.
Exactly. And as you can see on the map, this is where all our mining activities are located in the country.
So, Becky, what happened over the last 50 years?
Well, if you look over the last 50 years, when iron ore was the dominating export for the South African mining industry, this is what you typically find a mine to be, in a remote area, with plenty of space, resources like water, and there were no restrictions.
And nothing about the mining camp for the employees.
Actually, if you look now, fast forward to today, this is how the mining environment looks like. So many people have moved closer towards the mine, and remember the definition, we have to mine and remove resources from underground safely and environmentally friendly.
Okay, and if you can't grow it, you have to mine it.
Definitely. This provides now plenty of opportunities for mining engineers who are coming up into the industry now. Because if you can look, there are communities that are surrounding these mining areas. And of course, if you look at the environment, we have to keep it as we found it, or even better. And when we consider labor, we should actually consider hiring a lot of women into mining. Because according to South African stats, about 42% of South African households are actually female-led. That means if we hire more women, we're actually having a positive impact on the economy. The modernization of the industry can actually assist us to provide equal and fair, sustainable opportunities for the communities around the mining environment.
So, Becky, again, what I hear now is that you say, we're not going to employ less people, we're going to employ people to do a different type of job.
Definitely.
So, therefore, mining is either on surface or underground. Let's first look at surface environments. Any mining cycle consists of drilling, blasting, loading and hauling, and then supporting where needed. A good design for a surface mine actually looks at the slope stability.
That's brilliant. Actually, when you understand surface mining, you have to understand how exactly do we decide whether do we go surface mining or do we go underground?
The big drawback for surface mines, of course, is removing a lot of waste to get to the actual mineral. And that can also be the limiting factor. Economic extraction, that's mining.
Can you maybe explain why exactly do we choose to go surface mining instead of underground mining?
Well, surface mining allows us the opportunity to mine much lower grade and still being economically viable. So from the exploration, the geologists indicate to us the ore body being relatively close to surface. So therefore, a small amount of waste can be removed to get to the mineral, which we actually want for product.
That's very interesting. Now, can you maybe comment on exactly what type of mineral resources do we find on surface that are still available in South Africa?
Well, we typically mine gold. We know about the coal and the platinum industry, the massive mining in the iron ore industry as well, copper, uranium, and a whole list. Anything we mine underground is also mined from surface.
That's interesting. But I do believe that since surface mining is on surface, I'm sure when the blast happened, when water is being tainted with of the community, it does create some problems.
Yes, the challenges do exist. But all that, part of the mining engineers program. And we need to know how to challenge and then also rectify these risks.
Now, how deep exactly does a surface mine have to be for it to be unfeasible or infeasible?
Well, there's a nice trade-off on the economic side. You need to remove waste which doesn't carry any revenue. To get to the revenue, you need to optimize those two to actually make a profit.
Now, that's very interesting. Since we've done surface mining, let's look at what happens underground.
See you there. Coming from surface, the other environment might be to go underground. And that can range anything from several meters to almost 2.5 kilometers, even 4.
That is interesting. And I hear that in South Africa we have one of the deepest mines in the world.
Indeed, we are aiming at 4,500 meters.
But how is it really possible to mine at such a depth?
Well, going with depth comes with increased expenses. Therefore, unlike surface mining, we need much higher grade and quality of ore.
How is the quality of the ore that we need to go that deep to find it? What kind of ore is that?
At those depths, we are mining gold. That is a highly expensive material, and of course we know how to use that in jewelry, electronics, even taking it to space.
That is very interesting. So now, as we look at the underground environment, there are special challenges that are there significantly, like safety.
So now, with rock all around us, of course that's one of the biggest risks. We need to mitigate that, and therefore we need to have proper designs.
That's very true. And I hear that the temperature can go up to 50 degrees on the rock.
Yes, but luckily for us, there's some limits to that as well. We're not allowed to be working in areas which exceed certain limits.
Now, it is known that most of the mines usually would convert from a surface mine into an underground mine. But how are these really different in terms of the production cycle?
Similar to surface mining, the cycle includes drilling and blasting, cleaning, and then supporting. It's not just about the hardcore production, bringing out the rock, putting it to surface, making money. There's also areas of specialization.
Yes, of course. And that is why, when you look at specialization, if you work in a mine, you can typically be in management or you can be in production. And of course, the technical fields that are involved with that is mine planning. We have to plan for the mine to make sure that we know exactly where we're going to mine. Since we're underground, you can't tell each direction from the other. So you need to know exactly where you're mining and if you're mining the correct material.
That's correct, because the geologists tell us where the minerals are, and then from there, we need to get there.
Exactly. And of course, once we know exactly where these things are, we can start looking at rock breaking, which is also a specialization. How do we break this rock? Are we going to use explosives or are we going to be cutting this rock?
Well, the next field of expertise can include rock mechanics or rock engineering. Working with rock, that's the major contributor to fatalities on the ground.
Exactly. And of course, when you're looking at underground, since it's hot and people work there, it means we need air to get to those sections. Therefore, ventilation is part of that.
Fresh air, and then also to dilute noxious gases from the blasts.
That's very interesting. Now, when you look at also mine occupational health and safety, because people are working there, it's a dangerous environment, we need to make sure that health and safety are managed so that our people can work in a safe environment and, of course, can live longer.
The most important product coming out of underground is the miner.
And just like management, this brings us to risk management. Risk management spans throughout all of these professions. So whether you're in planning, rock breaking, or rock mechanics, you are actually managing risk that the mine actually faces every day.
Then, coming from the underground or a surface environment, being in a production field, there's also other opportunities for a mining graduate to actually then go off-site and also be involved in industry.
Definitely. And what happens is that you can either be on the finance sector or on the manufacturing sector. Now, if you look at finance, for instance, you can either work for a bank, or you can work for an accounting firm or a law firm, or you can actually work for the government, whereby you can be an inspector who goes and inspect mines, or work with the inspector of mines. And then you can also work in the manufacturing or original manufacturing companies that manufacture equipment that work in the mine, and then you can consult together with the mine or with that particular OEM company towards the mine. You can also be a researcher who focuses on technology and telling us about what the future of mining holds.
That's great, because that latches onto the department's drive towards postgraduate degrees, the Masters and PhD in mining engineering.
And now, welcome to the future of mining. Now, engineering explosive is a course that demonstrated a blast wall. We used to use a physical model to demonstrate this to the students in our department. And of course, we'll show you the process of blast design, the marking, the drilling, the charging, the timing, and the blasting of a tunnel underground. But now, a new technology has emerged and has been developed as a virtual blast wall, which demonstrates how can a tunnel be blasted by students without the efforts of being physically in a mine. Well, we begin by making sure that the students understand the interactive tracked gadgetry, which is used to mark the face, to drill the holes, and time the blast, and therefore initiate the blast. Then, right after blasting, they can see the results from the blast and see the areas in which they can improve. And of course, this includes a system which has a scoring mechanism that can tell them how well they did with the blast or after the performance of the blast. Now, navigating the fourth industrial revolution has caught up with the mining industry. And of course, the nature of work keeps on evolving. Therefore, the industry had to begin to prioritize on safety and efficient productivity. How do you do that? You can only do that by empowering operators with the newest technology in order for them to be efficient in their operations. This includes the Remote Operations Control Center that you can see. These control centers uses machinery that are controlled by people over thousands of kilometers away. This allows them to work in a safe environment and yet still achieve productivity, which is what we remotely call, or what we classify as, a controlled or remote controlled mechanization. This brings us to automation. We have semi-automation and full automation technology. This is currently used or retrofitted into machinery that was once operated by people, but now has to completely work autonomously, or automated in a sense. This is used to achieve high precision and efficient productivity, and of course, absolute safety during the drilling of hard rock or the cutting of soft rock in the cases of coal. Now, drones have been used, or are becoming regularly used in the surface mining especially, to map out the ground and to report on post-blasting fragmentation and quality of material that is being used, without excessive traveling by the mine personnel, and of course, making sure that they are safe. Other uses of drones includes that the mine will monitor the mine infrastructure using drones, environmental aspects around the mine and the surrounding environment, and of course, make sure that this information is presented in a real-time basis in a digital platform, which is also known as a digital twin. Well, now, since we said we are in the future, there are opportunities for you as an engineer to mine mineral resources from sources that are not so conventional. Let's look at marine mining. There are minerals that are being mined at the sea or at the bottom of the sea, which is called marine mining, just as it's done in Richards Bay here in South Africa. And of course, there are opportunities for you to go and mine outer space. As soon as the colonies on the moon or on Mars can be established, we can start mining asteroids that are in abundance. And of course, this will surely be the future of mining, to ensure that we keep on supplying all the minerals that we require for our primary inputs, especially for manufacturing. Well, guys, we hope you enjoyed our presentation, and thank you very much for being here. From me.
From our side, also, thank you very much for listening, paying attention, and hope to see you joining us soon.